Okay, welcome. In this short video lecture, we're going to discuss about a problem on Fourier series, and I hope it will make you learn some concepts. So here's the problem. We have been told that a function f of x has period 2 pi and is such a way that is defined as x squared in the interval minus pi to pi. So there are three questions for us to answer. First is to sketch the graph from minus 3 pi to pi, 3 pi, and then to show that the Fourier series of the function is given by pi squared over 3 minus 4 into cos x over minus 1 over 2 squared cos 2x plus 1 over 3 squared cos 3x minus etc. And then to give an appropriate choice of x that will give the series as pi squared over 6. So here the key things is that you have to remember that the function is of period 2 pi, and then it's defined by x squared only in the interval minus pi to pi. So therefore, when you draw the graph, you draw the graph in this interval minus pi to pi, and then use the concept of being 2 pi periodic to draw the portions of the graph in other intervals from minus 3 to positive 3. That's very key. So solution. So let this be our y-axis. This to be our x-axis. Let this be pi squared two pi squared, 3 pi squared etc. 0 minus pi, minus 2 pi, and then minus 3 pi, pi, 2 pi, and 3 pi. So minus pi squared, minus 2 pi squared, minus 3 pi squared, etc. So the key thing is that f of x is x squared in the interval minus pi to pi. So therefore, we draw this graph f of pi, which is pi squared in this given interval. So therefore, actually you can do this dotted lines to make you draw so the thing is that now from minus pi, so this is you choose an appropriate scale according to the graph paper you have or the space you have. So we know that at pi we'll have pi squared, and then at 0 we have 0, and then at minus pi we have pi squared. So it's a quadratic curve in this space. It's a quadratic graph. Then once you know this is you don't extend it so that now it covers from everything in the, you just draw one quadratic from minus 3 to 3. That's from because it's only given by this in this interval. So therefore, once you have done this length, then use it now to count 2 steps to know where this other end would be. So this other end will be translated here. Then this portion here will move here, And then this portion here will be at this point here. So therefore, the other limb will be also in this interval. And then similarly, this will move 2 steps to this point, this 2 steps to this point, and then this will come this point here. So this will be the sketch. So ensure that you draw smooth curve. So if you draw continuously from minus 3 pi to positive 3 pi, you get it wrong because you'll be assuming that the graph, the function f of x equals to x squared is from minus 3 pi to 3 pi. So you have, this is the correct sketch that you need to do. And then, so part B is to show the Fourier series of the function. So remember that Fourier series f of x is given by a naught over 2 plus summation n from 1 to infinity an cos nx plus bn sin nx. So an will be given by 1 over pi minus pi to pi f of x dx, which will be 1 over pi minus pi to pi. Our f of x is x squared and then dx. When you work out, you get 1 over pi x power 3 over 3 from minus pi to pi. And this will be 1 over pi into pi cubed over 3 minus pi cubed over 3 minus pi cubed over 3, so that a naught will be 1 over pi into pi cubed over 3, now plus pi cubed over 3, because this will be negative, negative. So this will be up 1 over pi cubed times 2 pi cubed over 3, pi and 1 pi here, so we'll have 2 pi squared over 3. So that's our a naught. An, by definition, is 1 over pi minus pi to pi f of x cosine of nx dx, which will be 1 over pi from minus pi to pi x squared cos of nx dx. So here you use integration by parts, then letting u to be this, dv to be this, so that an will be 1 over pi, and then x squared sine nx over n from minus pi to pi, and then from minus pi to pi, and then 2x into sine nx over n dx. What is bringing me to this step is to know the fact that I've let my u to be x squared, so that my du is 2x dx, and dv to be cosine nx dx, so that when you integrate v, you get sine nx over n. And we're using the fact that integral of u dv is uv minus integral of v du. So that is what is leading me from this step to this step. So an will be given by, so 1 over pi into 1 over n, putting in the limits for this term, sine n pi and then minus pi squared sine minus n pi, then minus, I factor out 2 over n minus pi to pi x sine nx dx. So negative, so this negative will have now sine of 180 multiples of 180 will give us 0. So therefore, this part, all of them will be 0, so that an equals to 1 over pi into minus 2 over n minus pi to pi x sine nx dx. So this just say an equals to minus 2 over n pi integral from minus pi to pi x sine of nx dx. Now we use integration by parts on this integral here, integration by parts. U to be this, dv to be this, so that du equals to dx, and then v is minus cos nx over n. So an will be minus 2 over n pi into, so minus 1 over n x cosine of nx from minus pi to pi minus integral from minus pi to pi of minus cosine of n x over n, and then dx. So an would be minus 2 over n pi into minus 1 over n x cosine of nx minus pi to pi, and then plus 1 over n, a factor of 1 over n because constant, from minus pi to pi nx dx. So an is minus 2 over n pi into minus 1 over n into pi cosine n pi minus pi cosine of minus pi n plus this part, remember, is 0, just 0, or 1 over n times 0. This integral goes to 0. This integral here. So an is minus 2 over n pi minus, so 1 over n, this is the same as pi cosine of n pi, minus is plus, and then cosine of a negative angle is a positive angle, so cosine n pi. So because this other part is 0. So an is minus 2 over n pi minus 2 pi cosine n pi over n. So which is minus 4 pi over n squared pi cosine of n pi. So this an is minus, so pi 4 over n squared and then cosine of n pi. But we know that cosine of n pi has two values, 1 and -1. 1 when n is even, when n is odd. So this can just be written as -1 raised power n. So therefore, an is -4 over n squared minus 1 power n. So we can say an has two values. So when n is even, so we have, so remember this was negative, this was a negative, this was a negative, so then this will go as positive. So negative, negative. So this negative here and negative cancels out, so this sign will be plus. So this is plus. So this is plus. So when n is even, and -4 over n squared when n is odd. So therefore now we have an, we have bn, and we have so we have not calculated bn, so let's quickly calculate bn. So bn is given by 1 over pi integral from -pi to pi f of x sine of nx dx. So which will be 1 over pi minus pi to pi of x squared sine nx dx. So also use integration by parts, so that bn equals to 1 over pi and then x squared into minus cosine nx over n. So remember, we are using integration by parts, letting this to be u, this part to be dv, so that v is negative cos nx over n. Minus integral minus pi to pi of v du, which will be given by 2x into minus cosine nx over n dx. So that bn is 1 over pi. This point here will have x, I can factor out minus 1 over n, then I say x squared cosine nx from minus pi to pi. And then I can put out 2 over n from minus pi to pi cosine nx dx, but it's an x here. So bn is 1 over pi into minus 1 over n, and then pi squared cosine of n pi minus pi squared cosine of minus pi n, and then plus 2 over n minus pi to pi x cosine of nx dx. So this would be minus. So you should see that bn is 1 over pi minus 1 over n. So this will be pi squared cosine n pi. Cosine of negative angle is positive. This is positive, so minus pi squared cosine n pi plus 2 over pi, 2 over n minus pi to pi x cosine of nx dx. So clearly you can see that this part will give us 0. so that Bn is 1 over pi into 2 over n minus pi to pi of x cosine nx dx. So which can be written as Bn is 2 over n pi integral from minus pi to pi x cosine nx dx. So also here, use integration by parts. So that Bn will be 2 over n pi into x sine of nx over n from minus pi to pi minus pi to pi sine nx over n dx. So remember here we have let u to be x, dv to be cosine nx dx. So which means du equals to dx and v equals to sine nx over n. So that's why you're getting this. So Bn will be 2 over n pi into, I put in the limits, pi sine n pi over n minus pi sine of minus n pi over n, and then I say minus 1 over n minus pi to pi sine nx dx. I've simply factored out 1 over n. So Bn is 2 over n pi. This would be pi sine n pi over n, minus minus plus, but this minus minus pi sine n pi over n minus 1 over n minus pi to pi sine nx dx. So Bn is 2 over n pi. So clearly you see this is 0, this part here, minus 1 over n minus pi to pi sine nx dx. So that your Bn is from here minus 2 over n squared pi integral from minus pi to pi sine of nx dx. So, and the integration of this is 0. So the same as minus 2 over n squared pi times 0. So Bn is 0. So therefore, f of x, a naught was given by 2 pi squared over 3. So dividing by 2, so we have a, so a naught over, so let's just write it, plus summation n from 1 to infinity an cosine of n x plus bn sine of nx. This by definition. And since we have found out that b is bn is 0, so all this part will be 0. So that we have f of x equals to a naught over 2 plus summation n from 1 to infinity an cosine of nx. Now, so a naught was given as 2 pi squared over 3, and an has two values. One is 4 over n squared when n is even. Another one is minus 4 over n squared when n is odd. So f of x will be replacing here. So this mod divided by 2, so we'll have a half into 2 pi squared, but this is 2, over 3 plus summation n from 1 to infinity of, just write an cosine of nx. So clearly you can see that f of x have 2 and 2 cancels out, so that we have pi squared over 3 plus summation n from 1 to infinity an cosine of nx. So we can list a few terms. So so therefore f of x equals to pi squared over 3 plus, when n is 1, which is odd, then we have negative sign. So we have minus 4 over n squared, really n, so just minus 4 So remember, an is 4 over n squared minus 1 raised to n. So 1 will give us negative 4 cosine of x, 2 positive plus 4 over 2 squared cosine of 2x, 3 negative, so 4 over 3 squared cos of 3x, 4 positive, which is even, so because it's even, 4 over 4 squared cosine of 4x, 5 negative because it's odd, 4 over 5 squared cosine of 5x, 6 positive because even, 4 over 6 squared cosine of 6x, 7 negative, 4 over 7 squared cosine of 7x, 8 positive, 4 over 8 squared cosine of 8x, 9 negative, 9 squared cosine of 9x, plus etc. So you observe that 4 is common in all of them. So we can say f of x equals to pi squared over 3 minus 4 into cosine of x minus, if I factor out a negative, so then I'll have minus 1 over 2 squared cosine of 2x plus 1 over 3 squared cosine of 3x minus 1 over 4 squared cos of 4x plus 1 over 5 squared cos of 5x, and then minus 1 over 6 squared cos of 6x plus etc. So that is what we have. Then lastly, to show that pi squared over 6 equals to 1 plus a half plus 1 squared plus 1 over 3 squared plus 1 over 4 squared plus etc. So we set, so let's call this one alpha, this answer I've got in here. Set x equals to pi. Set x equals to pi so that we have f of pi. So in that alpha equals to pi squared. So then now from alpha, we have pi squared equals to pi squared over 3 minus 4 into cosine of pi minus 1 squared cos of 2 pi plus 1 over 3 squared cos of 3 pi minus 1 over 4 squared cos of 4 pi plus 1 over 5 squared cos of 5 pi. So this is not squared, it's just pi. So then minus 1 over 6 squared cos of 6 pi plus etc. Now, cosine of pi, which is 180, is -1. So we have pi squared equals to pi squared over 3 minus 4 into minus 1, and then minus 1 over 2 squared into cosine of 2 pi. So cosine of 2 pi is 1. Cosine of 3 pi -1. Next will be +1. Next will be -1, etc. So taking this one to the left-hand side, so we have pi squared minus pi squared over 3 equals to -4 into -1 minus 1 over 2 squared minus 1 over 3 squared minus 1 over 4 squared minus 1 over 5 squared. Actually, next will be -6 squared minus 1 over 7 squared minus etc. So this 1 minus a third is 2 over 3. So 2 over 3 pi squared equals to, so I can actually multiply everything by negative. So I have 4 into 1 plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared plus 1 over 5 squared plus 1 over 6 squared plus 1 over 7 squared plus etc. This negative is what I'm making this one's positive. And then to get this series, then just divide both sides by 1 over 4. By 1 over 4. So this 4, 1, this 4, 1. So 2, 1, 2 here, 2. So the pi squared over 6 equals to this bracket here. 1 plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared plus 1 over 5 squared plus 1 over 6 squared plus 1 over 7 squared, etc. So that is how we're supposed to solve that problem. Have a good day.